Welcome. You are welcome to MTH 102, General Mathematics 2, Study Section 2, Representation of Functions. The concept of functions and its corresponding delineation, as well as its properties, are very crucial to the study of calculus. Simple observation of any physical phenomenon will make it imperative for you to be interested in how variable objects are related. For example, you are familiar with how distance traveled by a body freely falling in a vacuum is related to the time of the fall, and also the concentration of a medicine in the bloodstream is related to the length of the time between doses, and how the area of circle is related to the radius of the circle. In this study session, you will be learning about representation of functions with special reference on graphical methods. You will also learn about graphical representation of using basic elementary and transcendental functions. Here are the learning outcomes. 1. When you have studied this study section, you should be able to 1. Define the function, to define a function. 2. To discuss basic elementary functions, as well as to be able to explain transcendental functions. Definitions of a function. A function is a rule which establishes a relationship between two sets. Suppose we have x and y as two sets. A function f from x to y is a rule which attributes to every member of x belonging to x and a unique member of y belonging to y, as it is written on the board. Mathematically, just as we have, f is a function of x which reads from x to y. Also, a variable of y equals to f of x. In words, f of x reads f is a function of x, and this is the function of a variable x in the domain x of the function if to each value of x as a subset of x there is a corresponding definite value of the variable y as a subset of y. Basically, every function is determined by two things. 1. The domain of the first variable, and 2. The domain, the rule or condition of the set of ordered pairs x and y, and this must be satisfied to belong to the function. For example, let the domain of x be the set of x having these members: -2, -1, 0, 1, 2, and it's being assigned to the function y to be equals to 2x, like we have on the board, just like I underlined. Now for this case, what we are going to do is that we'll be substituting the value of x, that is, when x is equal to a so value, we input it into the function, then we yield the value for y. Like this, we have, take for instance, when x is equal to 2, when x is equal to -2, then we have y equals to 2 into bracket -2, so which is equals to -4. Also, when x equals to -1, our y is equals to 2 into bracket -1 equals to -2. And also, when x is equal to 0, when x is equal to 0, y equals to 0. When x is equals to 1, y is equals to 2. Also, when x equals to 2, y equals to 4. And so on and so forth. For instance, if each number in the set that is between 1 to 2, we associate a number y equals to x squared plus 1. Then the correspondence between x and x squared plus 1 defines a function. Methods of representing a function. There are two major methods with which a function can be represented, and these are analytical method and graphical method. Let's go over them one after the other. Analytical method. This is given by a formula which shows you how the value of the function corresponding to any given value of the independent value can be determined. 2. Graphical method. The graph of the function defined by y equals to f of x is the set of points in a rectangular plane whose coordinate pairs are also the ordered pairs, that is x, y, or x, f of x of the function. Basic elementary functions. There are 4 major basic elementary functions, and these are constant function, polynomial function, identity function, and algebraic function. Let's go over these basic elementary functions one after the other. Constant function. This is simplest function to study and is the constant functions. A constant function have only one constant value. Why? For all values to belonging of a constant function have only one constant value. Why? For all values belonging to the domain, that is f of x equals to a, just like we have on the board. That is for all x which are subset of x, where x is the domain of the function. Polynomial function. Any function that can be expressed as f of x equals to ax, that is f of x equals to a naught x raised to the power n plus a1 x raised to the power n minus 1 plus a2 x raised to the power n minus 2 up to x n minus 1 plus a raised to the power n, where a1, a2, a3 up to an are constant coefficients of a polynomial function of n degree. Identity function. This is a function that assigns every member of the set domain to itself. Let x, for instance, let x be the domain of the function. Then f of x equals to x for all x which are subsets of x. The graph of any identity function is a straight line passing through the origin. The fourth basic elementary function, which is the algebraic function, is defined as when two polynomial functions are combined together to construct a function of this form px all over qx, like we have here. Then we have a naught, that is a naught xn plus a1 x1 up to a raised by n all over b naught xn up to bn. Then the above function is called a rational algebraic function. Now, transcendental functions. They are known to be essential in describing or modeling physical dynamics. Transcendental functions are the functions that do not belong to the class of algebraic function, as discussed earlier. And these are the exponential function. Transcendental functions include exponential function. This function is known as the natural exponential function, logarithm function, trigonometric function, hyperbolic function, inverse trigonometric functions, as well as inverse hyperbolic functions. Now, the exponential function, take for instance a function f of x equals to a raised by x, where a is greater than 0 and a is positive or negative 1. This is called an exponential function. A special case is an exponential function where a is equals to the exponential itself. Logarithm function. Any function, take for instance f of x, which has the property that f of x comma y equals to f of x plus f of y for all x comma y raised by 0 is referred to as logarithm function. Trigonometric function. Any function which is of the form f of x equals to x, which is of function f of x equals to sine x or cos x or tan x or cot x or cosec x or sec x is referred to as trigonometric function. Inverse trigonometric function. The function defined as sine inverse x, that is f of x sine inverse x, f of x cos inverse x, f of x tan inverse x are referred to as inverse trigonometric function. Also, for hyperbolic functions, these are classes of functions that can be formed by combining the exponential functions together. Take for instance, we have f of x to be equals to exponential x plus exponential minus x all over 2, just like we have here. And this definitely gives us cos x. And also, if you have something of the form, that is, if the positive sign changes to negative sign, just like we have here, then we have, that is, f of x equals to exponential x minus exponential minus x all over 2, just like we have here, then give us sine x. Inverse hyperbolic function. The functions of the form y equals to sine inverse hyperbolic functions. The functions of the form y equals to sine inverse x, like what we have here, or of the form cos y equals to cos inverse x, are called inverse hyperbolic functions. Other ones are y equals to tan inverse this, tan inverse x, then sec inverse x, and cosec inverse x. With this, we have come to the end of study section 2, that is representation of functions. I do enjoy you to go further studying the other study sections to have a better understanding of what you have learned. Thanks for listening.